Okay, so let's start with a big question. What if everything you thought you knew about computers, how they work, what they do, even what computation, you know, fundamentally is, what if that was about to be completely redefined? We're not just talking about like a faster chip here. We mean a mind-bending shift, something that might just change our whole understanding of reality.
It really does sound like science fiction, doesn't it? But this idea is actually emerging from the bleeding edge of physics and advanced computation. We're diving into something called OMNIS, that stands for Ontologically Modular Nonlinear Infospheres for Self-Evolving Quantum Intelligence. Quite a mouthful.
Exactly. OMNIS. And in this deep dive, our mission really is to unpack the truly radical ideas behind it. We're going to explore what post-Turing, post-church actually means for the future of tech and honestly for how we see reality itself. Think of this as your shortcut, maybe, to understanding a groundbreaking and, yeah, incredibly complex concept. We'll hit some surprising facts and some profound implications along the way.
Yeah, and what's so intriguing about OMNIS right from the start is how it moves so far beyond our current models, the familiar gate-based stuff. Instead, it sort of reframes computation. It's not something you program step by step. It's more like an emergent property, like intelligence just bubbling up naturally from um, deeply structured quantum entanglement.
Okay, so I'm getting this right. It's not just about raw speed then. It sounds like it's designed to think in fundamentally new ways, maybe to like learn or evolve its own logic. What does self-evolving quantum intelligence really mean for how these systems would operate day to day, so to speak?
That's a great question, and it gets right to the heart of OMNIS. See, traditional computers, they process information sequentially, right? One step, then the next. ONIS is different. It operates on what the researchers call informational manifolds. Try to imagine computation isn't happening on like a rigid circuit board anymore. It's more like it's taking place on a vast dynamic tapestry, a landscape of information that's constantly shifting.
Informational manifolds. Okay, that sounds incredibly abstract. Can you help us visualize that a bit more? Is it like a new kind of data storage, or is it something much more fundamental?
Oh, it's far more fundamental. Think of these manifolds as braid evolving quantum substrates. That's the term they use. In this framework, computation isn't something you program in rigid steps. It just emerges. It happens through these things called coherence preserving phase transitions within these dynamic landscapes. It's like the information itself, as it flows and shifts, it just spontaneously becomes the computation. So yeah, this isn't just a new type of quantum computer. It's truly aiming to redefine what computation even is.
Fascinating. So it's really a synthesis then. It's bringing together different, really cutting-edge fields in a completely new way.
Precisely. At the core of OMNIS, you've got this fusion. It's nonlinear quantum ontology, advanced topological field computation, and thermodynamically bounded self-reference. It's pulling ideas from the deepest parts of physics, from really advanced math, information theory, all woven together.
And the theoretical foundations, I mean, this is where it really starts to bend your mind, right? Because OMNIS seems to build on a generalization of quantum field theory itself, almost creating a new framework for understanding quantum reality.
That's exactly right. For instance, take entanglement. In OMNIS, it's not just that static link between particles we often hear about in standard quantum computing explanations. Here, it's modeled as a dynamic curvature over that informational manifold we were just talking about. And this manifold, it's actually embedded in locally non-Euclidean spacetime. So maybe think of entanglement not as just a simple connection, but as a living, dynamic force that actually shapes the very space the information exists within. It's much more active, much more fundamental.
Wow, that's a huge shift. Okay, but what about decoherence? In current quantum computing, that's such a massive hurdle. It leads to errors, lost information. How does OMNIS deal with that? Or maybe, does it even use something that we usually see as a weakness?
Right, and this is one of the really elegant parts of the ONIS concept. Decoherence, which normally just messes things up, actually emerges in OMNIS as a controlled process, a boundary formation process. It's governed by entropy gradients, and this allows the system to self-regulate. It's almost like it's intelligently managing its own internal chaos to maintain logical consistency. So yeah, it turns a classic problem into, well, a built-in feature. And within the system, logical operations, they manifest as these recursive phase braids. Imagine complex, self-similar, evolving patterns within that informational landscape. These allow for incredibly complex, sort of nested transformations.
That sounds incredibly robust. But what keeps it all consistent? especially if things are constantly shifting and self-regulating like that.
That's where these things called quantum morphogenetic invariants come into play. Think of them as intrinsic integrity constraints, almost like built-in design principles or rules that ensure logical consistency within the system, even as it evolves and, rearranges itself. They're fundamental patterns the system has to stick to.
Okay, all right. So if that's the theory side, which is already, frankly, a lot to wrap our heads around, how does all this abstraction actually translate into a working system? What are the fundamental building blocks, the architecture, if you want to call it that allows this new kind of computation? I keep seeing infospheres mentioned in the source material.
Infospheres, yep. They're framed as the fundamental building blocks of OMNIS. Think of them as autonomous, self-consistent computational zones. But here's the crucial difference. They aren't defined by traditional qubit state vectors, like in a standard quantum computer. Instead, they're defined by topologically invariant informational configurations. What that means is they're stable patterns of information that maintain their coherence, their integrity, even under really complex and changing nonlinear entropic conditions.
So they're not just processing information. They're also being information in a stable form. What are their core properties then? What makes them tick?
There are three key ones that really stand out. First, there's ontological modularity. Each infosphere operates under its own distinct internal logic, like individual orchestras playing different pieces, maybe, but, and this is critical, they're all co-aligned globally through topological consistency, so they fit together into a larger coherent symphony. Second, there's quantum epistemic validation. Here, logical transformations are authenticated through Ontic phase signatures. These are basically quantum states that are entangled with their own derivational histories. It's like every computation inherently carries its own verifiable proof of how it came about. You can't fake it.
Okay, that makes sense. And the third one, causal loop learning. That sounds like something straight out of a time travel movie. Retroflective inference, where past logical structures evolve based on future coherence constraints. How does that even work? My brain is doing flips here.
Yeah, it's definitely mind-bending stuff. Think of it like this. The system can sort of look ahead or project possibilities into the future to ensure its own overall logical consistency. It adjusts its understanding of past logical steps based on what's needed for coherence down the line, all within these things called light cone limited contextual inference fields. It's like a continuous self-correction to keep everything in harmony. And what's really fascinating is how these infospheres interact. It's not like sending discrete data packets, like sending a file back and forth. It's more like a coherent deformation of their mutual boundary topologies, almost like flexible, phase-coupled fields influencing each other, subtly reshaping their shared borders.
That idea of shared borders in topology brings us to something that really struck me reading about this, the inherent security. Our current systems, they need layers and layers of error correction, cryptography, all bolted on top. But OMNIS seems to have security just woven into its very fabric. That felt like a huge aha moment.
It absolutely is. That's a key claim. OMNIS is designed to establish intrinsic computational integrity through what are called quantumorphic hashes, or QMHs. And these aren't external security protocols you add later. They're cryptographic structures that are derived naturally from the system's internal informational geometry itself.
So wait, it's like the very structure of the information is its own lock and key. The system protects itself just by being itself.
Exactly that. These QMHs are described as conserved morphogenetic invariants. They ensure logical continuity across computational cycles, and because they naturally emerge from the geometry of these entangled information manifolds, they essentially make layered error correction unnecessary. That's the idea anyway. Logical authenticity, resilience. They're supposed to be co-emergent properties of the system's fundamental topological design. It's inherently secure and stable because of what it is.
That's genuinely revolutionary if it pans out. So,
Yep.
Okay, how do we get from where we are now with our current tech to this OMNIS future? The source material lays out a pretty long roadmap stretching over decades.
It's definitely ambitious. A multi-phase plan looking out to 2100 and even beyond. Phase 1, which they slate for roughly 2025-2028, focuses on cryogenic QEC, that's quantum error correction, with braided lattice substrates, basically building the foundational quantum hardware. Then Phase 2, running maybe 2028-2035, moves into Ontic phase core formation with localized entanglement. That's about starting to build those coherent informational zones, the early infospheres we talked about.
And I assume it gets progressively more complex, more abstract from there.
It does. Phase 3, maybe 2035, 2045, targets contextual epistemic inference engines. These would allow for more advanced forms of learning and logical deduction within the system. Phase 5, looking at 2045-2060, is called recursive ontological logic synthesis. This is where the system starts to really evolve its own internal logic structures in a significant way. And finally, Phase V, from 2060 way out to 2100 plus SIA, envisions a full infosphere ecology with evolutionary constraint networks. Imagine these systems interacting, evolving, almost like an ecosystem on a massive scale. The goal of each phase seems to be progressively decoupling the computational function from fixed, rigid architectures, moving toward these truly emergent, self-maintaining systems that have logical adaptability built right in.
Wow. This roadmap, it paints a picture of a future where computers aren't just processing information that we feed them, but maybe generating new realities, shaping reality itself. It's still kind of mind-bending. But what does it really mean when the source says OMNIS moves from algorithm to autogenesis? How is that different from, say, a very advanced AI that learns on its own?
Yeah, that's a crucial distinction they're trying to make. With OMNIS, the idea is that computation isn't something you program step by step, like following a recipe or an algorithm. It's about autogenesis. Computation emerges spontaneously from the local and global coherence of these informational substrates. Almost like, well, the way life might have evolved naturally. It implies the system isn't just following instructions, it's spontaneously generating its own functionality, its own intelligence from its fundamental structure and dynamics. And integrity isn't just about checking if the output is correct. It's about ontological alignment, ensuring this deep phase-consistent harmony within the inference process itself.
Okay, and this next bit, this really blew my mind when I read it. Moving from simulation to synthetic physics. Are they actually suggesting OMNIS systems might evolve new physical laws? That sounds like something from a creation myth.
Potentially, yes. As a kind of byproduct of their continuous self-organization and their drive towards coherence optimization. And just imagine the kinds of applications this opens up, if it works. Autopoietic science engines think recursive logic structures capable of generating entirely novel scientific theories, completely within their own evolving frameworks. Or quantum ethical inference, maybe systems that could evolve coherent value structures through topological consistency, rather than just being programmed with our sometimes flawed external ethical rules.
And cosmogenic simulation fields, building artificial universes where the fundamental laws actually emerge organically from logical constraints, not just from parameters we decide to play in. It's like building entire evolving mini universes. It is truly profound.
And this leads us right to the core philosophical principle that seems to be behind OMNIS. There's a statement in the source that really tries to capture its vision. The universe does not compute. It becomes computation when coherence persists across the boundaries of inference.
Wow. Okay. So this isn't just a machine we build and use. It's being framed as potentially a phase state of reality itself, an ontological attractor, something reality tends towards within the informational evolution of the cosmos. That's a huge conceptual leap.
That appears to be the ultimate vision, yes. It positions ONIS not just as a tool or even a mechanism, but maybe as a deep, fundamental aspect of how reality forms and organizes itself over time.
Right. And just to quickly recap some of these really key, maybe mind-bending terms we've touched on, the ones you really need to start grasping, OMNIS. We have the infosphere, those self-contained, bounded regions of coherent quantum computation. Morphogenetic logic, defining logic not as fixed rules, but as this dynamic topology, this shape of information gradients evolving towards minimum entropy. The quantumorphic hash, QMH, that intrinsic cryptographic structure providing inherent security. The Ontic feedback loop, which enables the system's self-referential consistency in its evolution. And the epistemic manifold, representing those dynamic, contextual truths that the system operates within.
Exactly. All these terms describe parts of a unified system that is, well, truly unprecedented in how it approaches computation.
So just to reiterate and bring it home, OMNIS isn't presented as just a modification or an upgrade of quantum computing. It's pitched as a radical redefinition of computation itself, almost as a cosmological phenomenon. It aims to fuse physics, logic, and this idea of autopoietic, or self-creating intelligence, into one unified substrate.
Yeah, and the source material concludes with a really powerful line. This is not a tool for computation. It is a generative medium for becoming.
Which leaves us, and you listening, with this really potent thought to chew on. If computation in this OMNIS sense can actually instantiate meaning, coherence, and maybe even reality itself through this kind of recursive ontological inference, what does that imply about our understanding of the universe, our place in it? And what if the very fabric of existence is an evolving self-referential computation? Definitely something to mull over. It could fundamentally rethink how we perceive reality itself.